Yeah, so hello to the people recording. We just covered viewing the A365 tutorials on the YouTube channel. So if you haven't seen it already, make sure you go to the YouTube channel and watch those videos. It'll definitely help you get up to speed faster. And then afterwards, if you're interested in learning about Altium Designer, Altium has their own video series on YouTube that's pretty good. I would recommend it for anyone just starting out. So yeah, we're next just gonna do a really quick brief look at some schematic symbols. I picked this picture just because it had some of the stuff that we had on the tutorial board, so I thought it'd be helpful, but since we're not doing that board, it's fine. We still have all the main components that you'll generally see on board, so your resistors, capacitors, inductors, um, ICs, as well as, you might see some MOSFETs and diodes based on what board we're using. Generally, there aren't too many of our boards that use just a bunch of logic gates in this form. You might see some in their IC package, but yeah, you'll definitely see some MOSFETs. You'll definitely see diodes and resistors. So these are some of the really common schematic symbols you should generally know, or you'll definitely want to get familiar with as you work on. Because if you start looking at boards, you'll notice that these show up over and over again. There's some that are not on here, like I don't think transformers are on here, but most of the time these are just the common ones you'll notice. So for example, here is the tutorial board that Nita made for this sessions. So you can see that a bunch of them show up. So you can see the logic gates here. You've got diodes, capacitors, resistors, LEDs, connections. These are very common. You'll see on our boards, voltage nodes and ground nodes. So even if we're not doing this tutorial board next week, I still really recommend you go through it. Nita went through and documented pretty much everything she did here and has a video. So it's a really good way to get started with kind of looking at a board and understanding some of the way the components work. So here you can see most of the typical components you'll notice, so resistors, capacitors, etc. So it's good to get familiar with these, especially when you start looking at some of the more complicated boards. It'll definitely help you out. So in Altium, you can make custom symbols for components. You would go to your component and then you go to the symbol wizard here. You can use their generating tool. They have different shapes, and then you would go through and add pins. So for example, you could, let's say this wasn't already pre-made and you had to make it yourself. So you'd go through to components, add your symbol, and then you draw out the rectangle, go through labels, and add your pins in yourself. So that's generally the process. So if your component doesn't have any symbols, you might need to make it yourself. We do have kind of general best practices on Confluence, I believe, for making schematic symbols. If we don't have it up anymore, there's lots of good documentation online for how to make your symbols kind of standard and make it, you want to make it easy for people to understand what it is. So yeah, generally you'll use rectangles and then pins coming out. You'll label the pins from 1 and then however many pins you have. We have questions or comments. Yeah, so here's the video that Nia made. It should be accessible on Confluence and in OLEC hardware. So very similar to symbols are kind of the footprints of the components. So for example, here we have just a linear voltage regulator, but yeah, so you can see this is a component from our component library. You can see we have the footprints here. And also you can just notice that we have some of these other parameters we were talking about during the Kahoots, like manufacturer 1, manufacturer part number 1, and then supplier part number 1 are probably lower. But you can see here we have the footprints, but some components won't have footprints, so you pretty much have to make them yourself. It's pretty simple to do. You'll go through the footprint wizard and just go through that. The main reason you definitely want to have footprints is just it's really like you can't really make your board without having if your components don't have footprints. So what you'll do is you'll go through the footprint wizard, and it'll pretty much guide you through what to do. So you'll have to pick different parameters. So for example, if you're picking um, a pack, if your IC chip has this type of package, you'll use this package and you'll just go through and follow the specifications and fill these out. So you're wondering, where do you find these specifications? It's going to be off of the manufacturer specifications in their data sheet. And they do a very good job kind of like explaining it over. You can see all of the different specs labeled here. So you'd pretty much just go through this, find all the specifications, and use it to fill out the components. And then at the end, you'd have a footprint for your component. So this one is, I believe, for the very popular LM741 chip. I think it's from TI. Yeah, so this is kind of what you'd look at for when you're making your footprint for a component. You just go through and you fill out the parameters. Generally, it's good to have either someone look over it. Generally, you'd ask a lead to make sure it's up to like par, make sure you did it right. Um, but yeah, so if you definitely want to make sure you take a look at the specifications when you're making it. So the main kind of last thing we have is layout. So first thing about layout is take a look at the manufacturer specifications for whatever you have. So again, this is straight from the LM741 documentation, the same place we found their footprint information, but it kind of gives you an example of layout. It also helps you come up with ways to route components. So if you had, all these components you need to route, it kind of gives you an idea of some ways you could do it. You go like this under here. So that's definitely one thing to take a look at. So here is the tutorial board that we were going to use. We're not using anymore for those of you who missed it, but it's still good to take a look at. So just a couple things before we kind of look at the layout. You'll notice there's the logo board and the revision like we mentioned earlier. Um, oh, we have, oh, layout's been updated. Okay, so this is an older layout, but it still sort of serves the same purpose. So just looking at the board, can anyone in the chat want to give an example of like things they notice about the layout? No, no one. Like, is there anything you guys noticed that was like about the layout that either you think is like you're wondering why we did it like this, or like you're like, oh, this makes sense why we did something? Yeah, you'll notice there's like pretty much no right angles because as we mentioned earlier, you don't want to have right angles in your traces. It does look good. It has problems. It used to have problems manufactured, and I believe for some signals it can cause some problems. So yeah, no right angles. So yeah, if you take a look at some of the boards, there's a couple other things to notice. So the first is the placement of connectors. You generally want to try and have your connectors on the edge of the boards. You're not going to want to put your connector right in the like center. You also want to orient the way of the plug, because sometimes if it's the plugs on the other side, it can get hard to plug into the connectors. So that's another thing you want to consider with the layout. You also notice that a lot of the components are kept really close together. And that's because you also want to try and keep your the length of the traces shorter. So you'll notice that a lot of these components are kind of put close together in a way so that she need to like minimize a lot of the trace lengths. It's also, you'll notice that we also use, oh, and just hop back into the same link once it ends. But yeah, so you'll notice that we also, when we're doing layout, we have the silk screen here. So that labels, oh, it didn't end, never mind. Yeah, so we have the silk screen here to label all of the components. So you'll notice some really important ones are for ICs. You'll see the dot that lets you know the orientation of your IC. So this dot will line up to pin 1 of your IC, because generally ICs will have a dot indicating that it's pin 1. Another thing you might notice is a lot of so in some of the ICs, you'll notice that, I'm not sure if it's in this one or not, but we generally will use a rounded pin for pin 1. as another way, like the pad here, some of them would be, we'd round just the first one and keep the other ones square, just so it's easier to identify which one is pin 1. So another thing you'll notice is we generally don't put traces on the bottom, or if we're going to put trace on the bottom layer, it's going to be as few traces as possible, just because we want to use the bottom. We generally use the bottom plane for ground. So you'll notice there's barely any traces here on the bottom plane. Another thing to notice is we do use a keep out border. This is this is probably per the specifications of PLC PCB. I didn't actually check. Yeah, so no bottom traces in Europe. So yeah, you'll notice that on most boards there's generally like maybe just like a couple traces, if any at all, on the bottom layer, for the purpose of having the whole bottom as ground. You'll also notice we have a lot of vias here. It's a way to dissipate some heat as well. Sometimes you'll use it to, you will have different vias for connecting different like components from the top to bottom as well. Nita, do you have anything in particular you want to share about the way you laid out the board?
Nothing huge. I just want to point out that if you want to like interact with the board in any way, like for example, press buttons, turn some knobs like we do in this board, you just have to keep them like easily accessible. So you see the button is in the bottom corner, easily accessible. The resistor, the potentiometer is pretty big, so that should be easy to access as well. And the LEDs, they're both in distinct areas, they're not shrouded by other components.
Yeah, so for sure. Yeah, as Nita pointed out, there's a bunch of extra stuff. So there's a lot of considerations when you lay out your board. Liam, do you have anything else to add, or Ricky as well? Because you guys both lay out, you've done quite a few boards as well. Oh, okay. All right. So just kind of to follow up with layouts, I asked some of the leads for yeah, so you want to think about the return path of the current on the board. So thank you for that. So definitely, and that's another consideration you want to have, as Liam pointed out. So I asked the leads to kind of share some of the tips they have for laying out components. So James suggested today a really common one being decoupling capacitors. So you'll notice that in most boards that have ICs, including our tutorial board, if I can go back, we have a decoupling capacitor, and essentially their job is to try and deal with, like, whenever there's going to be a lot of voltage, there's going to be noise on your boards. So to protect your IC, it'll basically it's almost like a reservoir. So it'll act to oppose any of the big changes. So if the input voltage drops a lot, the capacitor will provide the power just to try and keep the voltage stable. And on the other hand, if the voltage spikes, the capacitor is going to absorb the excess energy. So so it's a pretty important component. You'll notice it's on a lot of our boards, and they generally protect our ICs. So you definitely want to consider the placement. So for example, if you had a decoupling capacitor, you want to place it in a way that it's as close to your IC as possible, just because the further it gets, the less effective it is. And you also want to try and keep it generally close to either like your voltage source or ground as well. So those are this is just one kind of example of something you would consider if you were laying out components. So one would be the decoupling capacitor. Another one I got from the leads was Liam recommended making sure you follow the Gerber checklist, and in particular the DRC rules. So for example, for those of you who don't know, if you go to our Confluence and you go to this link, you can find the design rules here. but you could also go to the website. And the reason this is so important is, first of all, you have to follow these whenever we make a board, because this is how we get them manufactured. But for example, if you find out that you need to have a really thick trace that's really large, you're going to have to consider that when you're laying out components. You have, like, if your thickness has to be a certain size, but you don't have enough room for it, you're gonna have to move components around. So that's another thing you'll want to keep into consideration. So it's generally a good idea to at least have like a general understanding of some of the rules that you have. So like the size of the vias and things like that. We do have this Altium does have a design rule checker that you'll generally use at the end, but it's at least a good idea just to have kind of an idea of what to take into consideration when you are laying out your boards. So here's just the Gerber checklist. I believe we're updating this right now just to make it more user friendly, but these are just some of the key kind of things. So you want to look at thickness of the traces. If it's a high current trace, it has to be sized properly. So as I mentioned earlier, you have to have a keep out trace, kind of like an area here around your board. So that would be another thing you have to consider. And you don't want to have any right angles as well. So does anyone have any questions for this session?
I have a question about signing into Altium.
Yeah, sure.
I tried to do it after I watched the tutorial videos yesterday, and I was able to make my own account, but how would I be able to see any of the design team's files or yeah.
Yeah, so to be able to access the files, I believe you need to contact any of the leads so they can give you access to join the workspace. Nita, can you confirm that that's still true? If Nita's still here. But yeah, so when I did it, I sent it to my account to Ashmika, and then Ashmika, our hardware lead, she added me to the workspace. So I think if you just post either in Elect Hardware or let one of the leads know that you would like access to a workspace, they'll give you access to the workspace. And once you're on there, you should be able to see all of the files and things like that.
Okay, all right, thank you.
Do you also have like a license for your Altium account yet?
Sorry?
Do you have a license for your Altium account?
No, I don't think so.
Oh, you should also talk to the leads about that. They can also help you set up it because you will need a license to be able to use like Altium.
Okay.
Yeah, does anyone else have any other questions?
I had another question about the general team meetings.
Yeah, sure.
I have like a conflict on some Wednesdays, and I'm not able to attend all of them. Is it mandatory to attend all the general meetings?
No, you don't need to go to all the general, like if you have things like that stop you from going to meetings, like don't worry too much about it. The main meetings you want to go to are the hardware meetings, because I'm assuming you're on the hardware team, right? Meetings are most important to like let people know what you're doing, like the progress you've made. If you can't make meetings, either talk to let's say you're working on a board and you can't make a meeting, you generally would want to either let one of the leads know or talk to Kristen, who is our PM for hardware.
Okay.
So if you let's say you had a test or something, you just didn't want to go to the meeting because you're studying, it's a good practice to at least let them know in beforehand. Or even if you do that, you might want to, we use Jira for managing our tasks. So let kind of like just leave like a thing like on there, like I'm busy with school, can't make a meeting, like this is what I have done this week or whatever, right? That way they don't need to like try and figure out, because a lot of times for boards and things, there's kind of like a deadline for when they need things to get done. So it's good if you can let them know in advance.
Okay. And then one more thing, I was looking at the safety training or the COVID checklist kind of thing, like the new COVID rules for getting into the bay, and I couldn't find how many people are allowed in the bay at one time. Do you know?
Yeah, so it should be 5 or 6 people. It says 5 on the bay door, but I think we had 6 when we were doing on-site training, so it's probably 6.
Okay.
So yeah, but as long as you've done all of, if you have you guys done the introduction, like the training for safety, the first safety sessions with that, I believe Catherine is running.
I did, yeah.
Okay, yeah. So once you've done that, I think next week Ashmika and Nita are running the on-site training. So if you go to once you go to that, you can just sign up on the calendar to go into the bay, as long as there's as long as everyone's under the limit of people.
All right, sounds good. Thank you.
Yeah, no worries.
And I just saw that because I'm using a Mac, I just saw that I have to download a Windows. I don't know what it is. Windows.
Like a VM, yeah. I don't know. I don't have a Mac, so I don't know how well it works. I think someone uses a Mac on our team. One of the leads might have a Mac, but generally, yeah. I think on Mac you can use um I forgot what it's called. I think you can use Boot Camp. Maybe you can either use Boot Camp or VM if you want to use Windows, right? So you can use Altium.
All right, thank you.
Yeah, no worries.
Or are you guys wondering about Altium?
Yeah, Altium for Mac.
Yes, I'm a Linux user, so I have to dual boot my computer to actually use Altium. It's apparently kind of crusty on virtual machines because it hogged a lot of resources. So a dual boot might be better for anyone who doesn't have a supercomputer.
Yeah. Did you just kind of relate to that? Have you tried Wine? Has Wine worked better for you, or do you just use dual boots or
I haven't tried Wine, because I've heard from forums that it just doesn't really work well.
okay.
I haven't had great experience with Wine.
Yeah, okay. So then since you're like I think you're the only one dual booting right now. So if you're using Linux, probably stick to the dual boot version.
You can dual boot on Mac as well. Windows is free to download.
There you go. Yeah, so I mean you can try that out, Matthew.
What's that one called?
Just regular dual booting Windows. So I think you have to use Boot Camp, right?
No, you don't.
Oh, you don't? Okay, never mind. No, the team has licenses. So once you let the leads know and they add you to the workspace, you should be able to use the team licenses. Yeah, no worries.
Are there like resources for like how to design boards and stuff?
Yeah, so a really good one
It's
is
like,
oh, sorry, go ahead.
no, you can continue.
Oh no, yeah, I was just gonna say a really good one is the first thing you'd probably want to look at, learn just Altium Designer in general. So Altium has free videos on YouTube. That would probably be a good place to start. Other than that, you'd probably have to go through Confluence as well as some of the old knowledge shares that we have on the hardware team. I think we might have a knowledge share for actually designing a board. I'm not sure if that's still happening or not, but if not, for sure, go through the Altium designer videos and then look through the Confluence because people have been working on boards for a while now. So there's a lot of good documentation on Confluence that would help you out. And of course, just showing up to board reviews would help. So whenever we just had a big board sent, I think we just sent out boards or we're going to send out boards. The people who are working on boards, the leads will generally go through them. So either Ashmika, Liam, James, or Nita will go through the boards and kind of help people like lay out their parts, like make them better. That's a good way to learn about laying out the kind of like how you make a board.
All right, thank you.
Yeah, no worries. All right, do we have any more questions? Okay, if not, we can stop recording and I guess we can end it here. I don't know how long I went. I was trying to keep it short.